function f of x equals 1 divided by the quantity x minus 2 plus 4, we want to find the domain, range, horizontal asymptote, and vertical asymptote. For this example, we'll be determining this information using a transformation of the basic function g of x equals 1 divided by x. So this video does assume we're familiar with the basic function g of x equals 1 divided by x, which is graphed here for review. Where for this basic function, the domain or set of all possible inputs would be all real numbers except x cannot equal 0, because if x was 0, notice how we'd have division by 0, which is undefined. The graph also has a vertical asymptote of x equals 0, which is this vertical line here. As the graph approaches x equals 0, the graph approaches the vertical line x equals 0, and as the graph approaches from the left side, again the graph approaches the vertical line x equals 0, but never touches it. The range or set of all possible outputs would be all real numbers except y can't equal 0. A fraction with a non-zero numerator can never equal 0. And the graph also has a horizontal asymptote of y equals 0, which is this horizontal line here. Notice as the graph moves to the right and moves to the left, it approaches the horizontal line y equals 0. Now from here, if g of x equals 1 divided by x, then the given function f of x would be equal to g of the quantity x minus 2, which means we would substitute or replace x with the quantity x minus 2 in the denominator, and then we'd have a plus 4. In this form, hopefully we can recognize that g of the quantity x minus 2 will be the graph of g of x shifted right 2 units, and the plus 4 would shift g of x up 4 units. Before we do these translations, let's review horizontal and vertical shifts using an animation. In blue we have the graph of g of x equals 1 divided by x, and in red we have the graph of the horizontal and vertical asymptotes. So in this form, looking at the equation here, a is 0 and b is 0. Let's see how the value of a affects the graph. Notice if a is positive, the graph is actually shifted left a units, and so is the vertical asymptote. If a is negative, notice how the graph is shifted right a units, and so is the vertical asymptote. So the value of a shifts the graph left or right. Now let's see how b affects the graph. If b is positive, the graph is shifted up b units, and so is the horizontal asymptote. And if b is negative, the graph is shifted down b units, and again, so is the horizontal asymptote. So by knowing these translations, we should easily be able to determine all the information that we need. So again, because we have g of the quantity x minus 2, we would shift the graph of g of x right 2 units. So we'll shift the vertical asymptote right 2 units. Should be here. The equation of this vertical line is x equals 2. And because we have the plus 4 here, we want to shift g of x up 4 units. So we'll also shift the horizontal asymptote up 4 units, which should be here. The equation of this horizontal line is y equals 4. So now we know the vertical and horizontal asymptotes of the given function f of x. Vertical asymptote is x equals 2, horizontal asymptote is y equals 4. Now let's graph f of x. This part of the graph, if it's shifted right 2 units and up 4 units, would have a point here. Then the graph would approach the vertical and horizontal asymptotes. And this piece of the graph would have a point here, and again approach the horizontal and vertical asymptotes. The set of all possible inputs or x values will be all real numbers except where we have the break in the graph at x equals 2. So the domain would be all real numbers except x cannot equal 2. Notice if x was equal to 2, we'd have division by 0, which is undefined. And the range or set of all possible outputs would be all real numbers except where we have the horizontal asymptote of y equals 4. So the range would be all real numbers except y cannot equal 4. Notice as x increases without bound toward the right, the graph approaches the value of 4 but never reaches it. And as x decreases without bound, or the graph moves to the left, again the graph approaches the y value of 4 but never reaches it. I hope you found this helpful.